Here we go, 8.5, using intercept form, our last section in wonderful chapter 8, second to last chapter of the school year. Okay, so go ahead and try the warm-up. So you're basically just factoring these expressions. So remember, again, really important, pause the video, try the problems yourself all the way throughout, unless it's like a new concept and you want to go through the first one watching me do it, that's fine. But when it's practice time, make sure you do the practice and then watch me uncover and do it. But go ahead and do this warm-up. You should be able to be good to go on factoring these expressions. Okay, so hopefully you got 2x minus 7, 2x plus 7, difference of two squares, right? 2x quantity squared, 7 squared. This one, x plus 4, x plus 2. Hopefully you saw no GCF, trinomial, not a perfect trinomial square because 8's not a perfect square. So you had to do star or old-fashioned and got x plus 4, x plus 2. Remember, you check these by multiplying back out. Okay, on this one, hopefully you got 2a plus 1, a minus 5. Again, no GCF, trinomial, not a perfect square trinomial. Had to do it star method or old-fashioned way. And then on this last one here, there is a GCF. It's x, and then that would leave us with x minus 3, and obviously it's a binomial. It's a difference, but not of two squares, so that's all we can do. Okay, second part of the warm-up says to write an equation in slope-intercept form of the line shown. So basically, you just had to kind of look at this, get the characteristics of this, and slope-intercept form, hopefully you remember it is y equals mx plus b. So what's b? That's our y-intercept. So looks like these are boxes worth 2 each. So our y-intercept is at 0, 4. So b is 4. And then we can figure out our slope. They've given us 2 points here that have integer coordinates. So we went what? Up 1, 2, 3, and then over 2. So our slope is 3/2. So hopefully you got y equals, that is not correct. It should be 3 over 2. 3 over 2 right here. Up 3 over 2. It happens. Okay, second one, hopefully you saw that the y-intercept was -2, and we would obviously be going down 2, 4, 6, and then over 1, 2, 3. So that's -6 over 3, which would reduce to -2. So hopefully you got y equals -2x minus 2. All right, moving forward, our learning target. I will know the characteristics of the graph of f of x equals a times the quantity x minus p, x minus q. That's going to be a new form that we're going to be learning about that will help us, and again, kind of make this more efficient in being able to graph and also to describe graphs. Okay, so work with a partner, you'll work with me. Each graph represents a function of the form f of x equals x minus p, x minus q, or negative x minus p, x minus q, where p and q are the x-intercepts, okay? So remember what an x-intercept is. It's where your parabola hits the x-axis. Write the function represented by each graph. Explain your reasoning. Okay. So go ahead and try those. Think about what P and Q would be for this one. Well, looks like these are each worth 1, and looks like we have an x-intercept at 1 and an x-intercept at 2. So P could be 1, Q could be 2, or vice versa, and it opens up, right? So x minus 1, x minus 2. And yes, the graph opens up and the x-intercepts are 1 and 2. All right, looking at B, you should be able to see that that one would be kind of similar. Looks like we have the same x-intercepts, but it opens down. So hopefully you put something along the lines of this. And it opens down and the x-intercepts again are 1 and 2. All right. So take a look at these. Which one would this be? Well, C, it looks like we have intercepts at 0 and at 1, 2, 3. It opens up. So it would be x and x minus 3. Okay. That actually, yeah, let's just leave it at that for right now. Okay, what about this one? Opens up. Where are the x-intercepts? Be careful with this one. X and then x plus 3, because remember it's x minus p, x minus q, right? So if it's a negative x-intercept, it's like x minus negative 3. You might be saying, well, where's the x minus 0? Well, what is x minus 0? It's just x, so they've simplified. Okay, how about this one? Hopefully you had x plus 1 and x minus 2 because the intercepts are at 2 and at negative 1. X minus negative 1 is the same as x plus 1. It opens up, so we're going to put a positive in front of there. Positive. We're just using 1 for right now. And then this one opens down, so it's a negative a, and then x plus 1 and x minus 2. Okay, our core concept here is if we have a function that is in the form of a times a quantity x minus p, x minus q, the x-intercepts are p and q. We've just talked about that. Okay. The axis of symmetry is halfway between p comma 0 and q comma 0. So if here's p comma 0 and here's q comma 0, the axis of symmetry would be right in between, right? Because remember, these y values are the same. So this distance from the axis of symmetry has to be the same as this distance, okay? So halfway between those would be the mean of them. In other words, the average, p plus q over 2, okay? So our axis of symmetry would be whatever that x coordinate is. We know the y coordinate's 0, right? So it's this line, this vertical line, p plus q over 2. And the graph opens up when a is greater than 0, and it opens down when a is less than 0. Okay, nothing new with that. Okay, so let's graph f of x equals negative x plus 1, x minus 5. Just from looking at that, you can see what your x-intercepts are. Okay, and if you know what your x-intercepts are, if you know what p and q are, then can't we figure out what the axis of symmetry is? So axis of symmetry, what's p and q? Negative 1 and 5. What's negative 1 plus 5 divided by 2? It's equal to 2, because that gets us 4, right? Okay, so that tells us what our axis of symmetry is. So you could actually go ahead and draw in a dashed line, or use a colored pencil or whatever, for your axis of symmetry at x equals 2. Okay, well, if we want to figure out the vertex, and we know that the x-coordinate of the vertex is 2, don't we just plug 2 in for x and figure out what f of 2 would be? Or in other words, what y would be? Yeah. So if we do that, we plug a 2 in there, we plug a 2 in there, and we have the negative still outside it. 2 plus 1 is 3. 2 minus 5 is negative 3. When we multiply that all out, we get 9. So what's our vertex? It's going to be 2, 9. Okay. Well, doesn't that tell us what our domain would be? Well, it's a function, right? And these parabolas go forever, so we know that one's what? Right, all real numbers. And our range, if it opens down, that means our vertex is the top point, right? The highest point. So that means our range, our y values, would be the y coordinate for the vertex and below that, right? So it would be y is less than or equal to 9. All right, so now you might say, well, how would I go about graphing this? Well, we have points that we can plot, right? We have the vertex, we have our axis of symmetry, we actually have 2 other points, don't we? We have the x-intercepts, and we know that the x-intercepts were negative 1 and 5, so one point we could plot would be negative 1, 0. The other one would be 5, 0. And then we could always plug in other points too, and then reflect it. But we could also just at this point kind of work off these 3. Okay, so there's our vertex, there's our 2 x-intercepts, and we kind of drew the curve in. If you wanted to make it even more accurate, yeah, we could pick another point. Setting y to 0 is always a good one to do. And we would end up getting 5 for that. Okay. I'm sorry, setting x equal to 0, right? And then figuring out what y would be, and y would be 5. Okay. And then we could reflect that point and add another point here, and then we would have had 5 points. But you really, in this case, don't need to have 5. All right. Moving forward, let's try this one. Graph f of x equals 2x squared minus 8, and then we're going to describe the domain and range. All right, similar thing here. Notice that we can factor out a GCF. And if I do that, what's left? Oh, a difference of two squares, which can factor to what? X plus 2x minus 2. So here we are. We can see what we're in x minus p, x minus q, where p and q are -2 and +2. So how do we figure out our axis of symmetry? It's just the mean between the x-intercepts. So the mean of those would be -2 plus 2 divided by 2, which equals 0. So what's our axis of symmetry? X equals 0. X equals 0, yeah. So you could basically see that the y-axis is our axis of symmetry. Okay. Which we kind of knew was going to be the case before that we even started this, didn't we? We know that this, when it's a constant here of -8, that means it's going to be a vertical translation down 8 units. And we know it's going to open up. Okay, so actually based on that, we could even figure out what the vertex is without even plugging in 0 for x. But if we did, we see that this goes to 0 and we get -8. So f of 0 is -8. So our vertex is 0, -8. So you can go plot that point. What other points can you plot? Oh yeah, the x-intercepts, right? -2, 0 and 2, 0. You could pick another point if you wanted to. At this point, we don't really need to. What's the domain going to be? Yeah, all real numbers. And what about our range? Well, our parabola opens up, which means our vertex is the bottom point. So what would the range be? Hopefully you got y is greater than or equal to -8. And this is what our graph would look like. Okay, awesome. So let's graph this one, and then you're going to include the vertex, the axis of symmetry, the x-intercepts, describe the domain and range. So go ahead and give this one a shot, and then pause the video, try it, and then come back. Okay, so we can see that we've already got it in x minus p, x minus q. So what are p and q? -2, +3. Hopefully for the axis of symmetry, you took the mean of those, and you got 1/2. Okay, so you could put in your vertical line of symmetry at going through every single point that has an x coordinate of 1/2. All right, well, we need to find the vertex. So what do? We got to set x equal to, plug in 0.5 or 1/2 for x. If you do that, hopefully you got -6.25, right? Because this becomes 2.5, this becomes -2.5, and that when we multiply those, get -6.25. So your vertex is 0.5 or 1/2, -6.25. Okay. So you've plotted those points. You know that it opens which way? Up, right? Domain, all real numbers. You've plotted this, so what would the range be? Y is greater than or equal to -6.25. Okay. Notice here, I actually plotted another point. I plugged in 0 for x, and if I plugged in 0 for x, then I get 2 times -3, which is -6. So I know I have a point that would go there. Can't I reflect that and also put another point in right here? So it just kind of gives us a better sense of what the parabola would look like. Okay. All right, so let's try another one. What form is it in? Yeah, already in intercept form or x-intercept form. So we're good to go with that. What do we notice? Ooh, okay, we see a -2 for a, which means it's going to be what? Yeah, opening down. And it's going to be a vertical stretch of our parent function. Okay, so go ahead and give this one a shot. Go ahead and graph it as you go, and then uncover or start the video up again. Okay, so axis of symmetry, yeah, would be the mean of our x-intercepts of 4 and -1, so we get 1.5. Then you plugged in 1.5 for x to figure out what the y-coordinate would be of our vertex, and you ended up getting 12.5, hopefully. Okay, so what is our vertex? It is 1.5 comma 12.5. So hopefully you've plotted 3 points now. You've plotted our vertex, and you've plotted our two x-intercepts at 4 comma 0 and at -1 comma 0. And you also have your axis of symmetry on there. Okay, so you should have this point, you should have this axis of symmetry, and you should have these 2 points. Okay, and then you can see what I did was I just picked another point and plugged in, and then saw that, then obviously reflected it across. So it looks like probably what I did was maybe plugged in, I'm not sure what I did. I plugged in something here. Maybe I plugged in 10 for y and then solved. Anyway, okay, it doesn't really matter if you didn't do that, that's okay. So what would our domain be? Yeah, it's a function, so it's all real numbers. What's our range? If you got y is less than or equal to 12.5. Okay. Here's why. I said by multiplying out the function, we know the y-intercept is 0, 8. Okay, so how do we know that? Well, if we multiply out, isn't that, ax squared plus bx plus c, or in this case k, wouldn't that be what our y-intercept is? It sure would. Okay. Okay, so go ahead and do this one. This one you can see is not in vertex form to start with. You could do this a number of different ways, but they do want our x-intercept, so let's go ahead and do it using what we're practicing right now. So what would you do first? Hopefully you said, I'll factor out the GCF and realize it's the difference of 2 squares, and I get x plus 1, x minus 1. So what's our axis of symmetry? It's the mean of our two x-intercepts, which are what? -1 and 1. So that's -1 plus 1 divided by 2, which is 0 divided by 2. So x is equal to 0, so which means our y-axis is our axis of symmetry. Okay, what is going to be our vertex? Well, a couple ways you can think about it. You could plug in 0 for x, and obviously you get -4, so it would be 0, -4. Or you can realize, since this is in the form of ax squared, plus c, in which case c is a -4, we know that this is just going to be vertically translated down 4 units. So it's 0, -4. All right, so when you went and graphed it, you should have had this point, and this point on there. Certainly you could find another point and plot it if you liked. To do so, you certainly could. What's our domain? Well, since it continues forever, it's all real numbers. And what would our range be? Greater than or equal to -4. Awesome. Okay, let's move on to the second half of the unit. All right, so remember, functions have zeros and graphs have x-intercepts. Okay, but remember, when we say what are the zeros of the function, what are we asking for? We're asking for what the x-intercepts would be of the graph. So they're basically meaning the same thing. Okay, well, if that's the case, if you're asked to find the zeros of a function, like in this problem, doesn't that mean we're just finding what the x-intercepts are? Okay, and we remember that from section 8.2, where you learned that a zero of a function is an x value for which f of x equals 0. In other words, when y is equal to 0. In other words, your x-intercepts. Okay. And you can use x-intercept form. You can use the intercept form of a function to find the zeros of the function, right? So if we can get it to x minus p, x plus q, we can just look and see what the x-intercepts are. And remember, that's what the zeros are of the function. Okay, so if we're looking at this one, right, we just set y to 0 or f of x to 0, right? And that's going to tell us what our zeros are. It's whatever x equals, right? And we knew that just from looking at the form. But you could set it into 0. So wouldn't be a faster way to find the zeros of a function be use the following? For any factor x minus n of a polynomial, n is a 0 of the function defined by the polynomial. It's kind of a lot of words in letters to basically say, okay, what's p and what's q? 1 and -2, right? Notice that if we set each of these equal to 0, isn't that what x is going to equal? Okay, so it's really as simple as that. All right, so this one here, find the zeros of each function. What do you notice about this one to start with? Is it in the form that we want? Is it x minus p, x minus q? No. Okay, so what do we need to do? Yeah, we need to factor it. So take out a GCF if there is one. So hopefully you took out a -2, and then you were left with x squared plus 5x plus 6. Should you try and factor that? Of course, we're not to the form that we want yet. So it's a trinomial. Is it a perfect square trinomial? No, it's not. 6 is not a perfect square number. Can we easily factor it? Yeah. You could use star method or old-fashioned way. It's pretty easy here. It's x and x. Signs are plus and plus. What factor of 6 is going to get us a sum of 5? 3 and 2. Okay, so what are the zeros? Well, again, you can just kind of look at it and say, what are p and q? Remember, it's x minus p, x minus q. So that would be the same as x minus -2, x minus -3. So -3 and -2. Okay, try this next one. Okay, well, we can see x minus 1 is fully factored. It's a binomial. It's a difference, but not of two squares. X squared minus 16, though, is not fully factored. X plus 4, x minus 4. So here, we actually have a function that has how many zeros? 3, right? So that's not going to look like a parabola. It's going to kind of look like something like that, right? And notice that if we multiply this out, it's actually not a quadratic function or something where our first term is x squared. It would be what? A cubic function, because it would be x cubed. Okay. All right, so let's go ahead and practice these. See if you can get these, and then start the video back up. Okay, this one is already factored for us, so we can just kind of look at this. Hopefully you saw that the zeros are just 1 and 6, or 6 and 1. This one, not factored, so you got to factor it. Take out the 3. What does that leave us with? X squared minus 4x plus 4. Trinomial. Is it a perfect square trinomial? Yes, it is. What does it factor to? X minus 2 squared. How many zeros do we have here? Well, we could list it as x minus 2, but isn't that going to just get us 2? So in this case, this is a parabola that just has 1 0. In other words, it only has one x-intercept. Okay. Try this one. Fully factored? No. Difference of two squares there. What are our zeros? -1, 0, and 1. So again, this would be one that has 3. So this would be kind of like something like that, which would cross the x-axis 3 times. Okay. So go ahead and let's try to use zeros. So again, it's using the x-intercepts to graph this function right here. Okay. So, what do we know? Well, we know x-intercept is 0, -3, right? Because that's what's here when it's in this form. Okay. What else do we know? It opens up, right? Because A is a positive 1, okay? We need to figure out the zeros, right? Because it said to use the zeros. So what would we need to do with this? Hopefully you said factor. And what would that factor to? X minus 3, x plus 1. So what are the zeros? -1 and 3, okay? All right, so notice what we have here. We have a point that's the y-intercept. We have our two x-intercepts. We don't have our vertex yet, and we don't have an axis of symmetry. So we kind of need that, right? So let's get the axis of symmetry. How would we do that? Oh yeah, we take the average of the two x-intercepts. So -1 and 3 are zeros, which is the same thing as x-intercepts. Take the average of that, and we get 1. So that tells us what our axis of symmetry is. So hopefully you filled that in as well. And now we need to get the vertex. And then once we have that, we can just plot all the points and we're good to go. So how would we figure out the vertex? Well, we know the x-coordinate, right? Because the vertex is always on the axis of symmetry. So we have to plug in 1 for x to figure out what h of 1 or what y would be. And if I do that, 1 squared is 1. That gets me a -2 and a -3. Combine 1, -2, and -3 together, and I get -4. So our vertex is going to be 1, -4. So hopefully your graph looked like this. We had our axis of symmetry. We had our vertex of 1, -4. Here's our y-intercept. What's nice about that is once I have that point there, I know, since it's a parabola, it's going to be symmetric. So if this is 1 to the left of our axis of symmetry, I know I can plot another point, 1 to the right. And then I had my two x-intercepts, which of course are symmetric as well. This one is 2 to the left of the axis of symmetry. This one, therefore, 2 to the right. Okay, so go ahead and try this one on your own and then start the video back up. All right, well, we know it opens up. And hopefully y-intercept, how would you figure that out? You could multiply the two binomials out, right? And we would get x squared minus 5x plus 4. So doesn't that tell us that our y-intercept is 0, 4? Okay. It's not our vertex, it's just our y-intercept. So it's a point that's going to be on our parabola. It's already here in kind of x-intercept form. So the zeros are going to be just what? 1 and 4, which gives us two other points that we can plot. We need to get that axis of symmetry and find that vertex still. So hopefully you took the mean of 1 and 4, which is 2.5. And then use 2.5, plug that in for x to figure out what our y value of our vertex would be. So if I plug in 2.5 and subtract 1 from it, I get 1.5. And if I have 2.5 minus 4, I get -1.5. Multiply those together, and I get -2.25. So what's my vertex? 2.5 comma -2.5. Not exactly the easiest one to plot, but certainly just do your best with it. So there's our vertex, there's our axis of symmetry. Notice our two zeros, our two x-intercepts of our graph are both the same distance away from the axis of symmetry. Here's our y-intercept, and I can see that my y-intercept is 2.5 units to the left of my axis of symmetry, which means I can go 2.5 units to the right and plot the next point. Well, what's 2.5 units to the right of 2.5? 2.5 plus 2.5, which is 5. So I can put a point here at 5, 4. Awesome. Okay. Use zeros to graph the function. Okay, so go ahead and try this one. Again, plot points as you go. Okay, so obviously not in intercept form, x-intercept form. So, but what we do notice is that I can pull my y-intercept here. It's going to be 0, -12. I know it opens up because a is a +1. I need to figure out what my axis of symmetry is, and I can figure out what my zeros are. So hopefully you factored and got x plus 4, x minus 3. What are our zeros going to be? Well, this is the same as x minus negative 4, so negative 4 and 3. Axis of symmetry, right? It's just the mean of those two. So what's the mean of negative 4 and 3? Negative 4 plus 3 divided by 2, just negative 1/2. So you've got these 2 points plotted, negative 4, 0, 3, 0. You've got your y-intercept plotted at 0, negative 12. We have our axis of symmetry. We just need to figure out that vertex. So what do we do with the x? We know the x-coordinate of our vertex is on the axis of symmetry, so it's negative 1/2. So plug that in for x. And if you do that, you're going to end up getting negative 12.25. How do I do that? Negative 0.5 plugged in there for x. Square that. That's going to get you a what? Positive 0.25. Obviously a negative 0.5 and then a negative 12 is going to get you negative 12.25. So your vertex is negative 0.5 comma negative 12.25. Your graph should have looked like this. There's our vertex. There's our 2 x-intercepts. There, right there is our y-intercept, which you can see is what? It's half a unit to the right. So we can plot another one half a unit to the left. All right. Write a quadratic function in standard form whose graph satisfies the following condition. The vertex is negative 3, 4. That's all we're told. So it can be, obviously, you probably recognize that there are an infinite number of quadratic functions or parabolas that you could have it go through a vertex of negative 3, 4. Okay? Does it say you need to do one that's super challenging and hard? No, it just says do one. So let's not make it too difficult on ourselves. So let's take a look at the study tip. It says, in part A, many possible functions satisfy the given condition. We just talked about that. The value A can be any non-zero number. To allow for easier calculations, let's have A be 1, okay? If we let A be 2, then, it's a little bit more tricky. We could still do it. So this is vertex form, right? Wouldn't it make sense that we want to start by plugging into vertex form if we're given the vertex? Yeah, of course. So what would negative 3 and 4 get plugged in for? Well, remember, this is the x, h is always the x coordinate of our vertex, and k is the y coordinate, right? So I'd plug in negative 3 for h, so minus negative 3 becomes a plus 3. The 4 goes in for the k. We just decided to set a equal to 1. And then basically, can't we just solve this and put it into standard form, ax squared plus bx plus c? Sure. Square your binomial. First term squared is x squared. Double the product of the two terms is 6x. Square the last term is 9. If we multiply all that times 1, it basically stays the same, right? And then we still have the plus 4 here. Combine our like terms, and we're x squared plus 6x plus 13. Okay. All right, so let's try some of those. Now this one on the left is a little bit different. Write a quadratic function in standard form which satisfies the following conditions. Here they don't give us the vertex, they actually give us the x-intercepts. So wouldn't it make sense that we would use this form instead, our x-intercept form? Yeah, of course, right? We want to use the information we're having. Do we want to make this super complicated and make a fraction or a decimal? You could. I'm not sure why you would. Probably easiest just to set a equal to 1. So we're going to plug in negative 1 and 1 for p and q. So you have x minus 1, x plus 1. Okay. Again, let's just, a can be anything. So let's just make it a 1, right? Got to put it in standard form. So what's the only thing I have left to do? Multiply it out. Conjugate binomials. Multiplying times 1 is not going to do anything. So you get x squared minus 1. Okay, here, they gave us a vertex. So of course, we're going to want to use vertex form. Does that mean you need to know these formulas? Of course it does. You're not going to be just given those. So you have to make sure that you know what they are. So here's our vertex form. And we have 8, 8. that would be plugged in for what? Hopefully you said h and k. Square your binomial. Multiplying by the 1's not going to do anything to it. So we would have x squared minus 16x plus 64 from squaring the binomial. And then we have the plus 8. Combine your two like terms. And voila, there we have it. Okay. All right. Here's one where we have 3 points. Notice 2 of these points are what? Hopefully you said x-intercepts, right? How do we know that? Because y is 0 for these two. And then this is just another point, okay? So what do we know? Well, we know the given points indicate the x-intercept. So let's use x-intercept form, right? So let's plug in for p and q. So here they plugged in minus 9 for p. So x minus negative 9 is the same as x plus 9. Negative 2 for q. X minus negative 2 is the same as x plus 2. Okay. What about this other point? Well, let's use the other point to find the value of a, right? Because this is a particular parabola. There's not a whole bunch that go through this. There's only one, right, that are going to have these x-intercepts and go through another point. So we actually have to figure out exactly what a is in this case. Well, again, remember, what do these points represent? They are solutions to whatever the equation is for that function, right? Which means that we can plug in negative 4 for x and 20 for f of x or y. So that's exactly what we did here, okay? And then what's the only variable that's left? A. So let's simplify this. Negative 4 plus 9 is 5. Negative 4 plus 2 is negative 2. Multiply those together, we get negative 10. So we have negative 20 equals negative 10a. Divide both sides by negative 2, we get a equals negative 2. Okay, well, now we know what a is. We know that we can plug a negative 2 in for a. Here is our intercept form, right? Y-intercept as x-intercept form, okay? And then they said standard form, so all we have to do is multiply it out. Okay. So why don't you go ahead and try this one, okay? Similar problem. They gave us 3 points. 2 of them are very special points. Well, all points are special, but these are very special ones. Notice we have the x-intercepts. So we can plug in for p and q. We know 3, negative 16 can be plugged in for what? X and f of x, because they're a solution to whatever the equation is for this function. Solve for a. Plug in 2 for a. Hopefully you did all this. And now what do we need to do? Standard form. Multiply out. Do it any order you want. I probably, multiply the two binomials first, right? So x squared, negative 4x, and 5x makes positive 1x. 5 times negative 4 is negative 20. And then just distributed the 2. All right. Exit ticket. Here we go. Okay. Use zeros to sketch the graph of negative x squared minus 7x minus 10. All right. Got to get it right. Go for it. Try it. All right. So hopefully you realize if we're using zeros, we need to get it into x-intercept form, which means factoring it. So I factored out a negative to make this easier to do. Hopefully you saw that using star or old-fashioned, x plus 5, x plus 2. So what are our zeros? Negative 5 and negative 2. That gives us a couple of points that we can use, right, on our graph. What are those? Yes, negative 5 comma 0 and negative 2 comma 0. What is the x-intercept, or x-coordinate, excuse me, of the vertex? Isn't that going to be on the axis of symmetry, which would be what? It would be halfway between those. In other words, the mean of negative 5 and negative 2. Negative 5 plus negative 2 is negative 7 divided by 2 is negative 3.5. Okay. What do we need to do next? Well, we have our axis of symmetry, x equals negative 3.5. Got to figure out that vertex. So hopefully you plugged in negative 3.5 for x. Y, or g of x, ends up being 2.25. So that just gave us our vertex. So we can plot negative 3.5 and 2.25. We now have got 3 points. What's my y-intercept? Oh yeah, from this form, I know it's just the negative 10, so I could plot 0, negative 10. And since I know that this parabola is symmetric, I know that I'm going to have another point that's going to be what? If this axis of symmetry is at negative 3.5, my y-intercept is 3.5 units to the right of the axis of symmetry, so I know I can plot a point that's 3.5 units to the left of the axis of symmetry. Negative 3.5, or 3.5 and 3.5 is 7, so I know I'm at negative 7, negative 10. So should have looked like this. One thing I don't have in here is our axis of symmetry. If I put that in, it would look like that. And you can see how everything lines up. So when I had that y-intercept at 0, negative 10, again, you can see how this is 3.5 units to the right. So I'd want to go 3.5 units to the left. All right. Well, that takes care of Chapter 8. Again, a lot of information here. Hopefully go back. Hopefully you paused it, rewound when you needed to. Make sure that you also try the Dynamic Student Edition if you feel like that would be helpful. It's another great source. And take advantage of contact time. I'm here to help you. Make sure you get those formulas, kind of in that noggin of yours, and you should be good to go. All right. Talk to you later.